Hello everyone, my name is Srivathsan and I'm here with Toby. We are from the machine learning platform team at Intuit, and we are here to talk about how the Intuit machine learning platform allows Intuit's data scientists and ML practitioners to manage ML models at scale. An overview of who we are. You might all know the products that Intuit offers for our consumers, our small businesses, and self-employed. Intuit is in the business of enabling prosperity for everyone who uses our products. And now it is more important than ever that we live true to Intuit's mission. And ML is a huge part of Intuit's mission. You can see ML in action in various products across our portfolio. For example, in TurboTax, the self-help feature of TurboTax, which looks at what help articles to surface to you, has an ML model behind that, which is predicting that. Similarly, in QuickBooks, a cash flow forecast for a small business can be incredibly important for them to predict how their cash flow is going to be for the days to come. And an ML model is crunching a lot of data behind the scenes in order to provide them with this prediction of how their cash flow might look like. And in Mint, you might have seen, users of Mint might have seen their transactions being categorized automatically using machine learning models. These are but a few of the ways that ML drives experiences for the products that Intuit customers use. However, we have also heard from our data scientists that managing models in production is extremely hard. In 2018, this is an actual quote from a data scientist where they said that they spend more time bringing a model to production than developing and training. As practitioners in the ML world, we have all seen the hidden depth of ML. We like to visualize this as an iceberg, with the tip of the iceberg being the data science work, and the part that's underwater is the operationalization and infrastructure management capabilities. So as we started building our ML platform, we asked ourselves, how can we make sure that our data scientists are able to focus on their craft? And that's how we came up with a delineation of the ML platform, what the ML platform does and what our ML practitioners do. The ML platform wants to take the burden of operationalization and infrastructure management away from our practitioners so that they can focus on their craft, on building great models, on building fantastic experiences that put more money in our customers' pockets. The machine learning platform is built on principles of collaboration, self-service, and security. We want to enable our data scientists and data engineers to collaborate freely and share models and share features in a self-service manner while providing world-class security and compliance for their models. We also want to enable the ML platform to be useful for a number of different personas across the company, for data scientists, for ML engineers, for data analysts, product managers, and marketers, to do the things that they need to do in order to make our customers, you, successful. We think of the generic model lifecycle as having these key components of ingestion and curating of the data, exploring the data, processing features, and generating really high quality features that can then be searched from a feature store, using these features to train models, and then using these trained models to infer online and in a batch fashion. And a model efficacy feedback system that can then provide feedback across all of these stages. These stages are then orchestrated using orchestration tools and model lifecycle management. The focus of our talk today is going to be around the areas where Intuit's ML platform has heavily invested in, around feature processing, feature stores, how we train our models, how we infer our models, and provide a lot of guardrails around these models, which then enable the self-service and speed. The ML platform is built on a host of technologies. We are entirely in AWS, and we leverage AWS SageMaker for a lot of our inference training use cases. And our workflows are orchestrated using Kubeflow and Argo. We use Beam and Spark for data processing in feature engineering and feature processing. And we have a number of Spring services which enable us to build the control plane of the machine learning platform. Let's now talk about the feature store. The feature store, we think, should be a collection of well-curated, high-quality features that are available for use across the company, and these features are kept updated and they are explorable and reusable. To that end, we have built a feature store which provides a high bandwidth ingestion capability to the tune of millions of events an hour, and APIs to manage features, feature versions, and so on, SDKs for ingestion, consumption of features, and tools for exploration of features. All these features are stored in two different stores: an online store for transactional, high volume, low latency access to features for use cases such as the self-help or the cash flow forecasting, where you really need the features just in time for you to do a prediction. The other store is an offline store where we store the features so that they can be used in a batch context, such as during model training or during batch inference. Some of the models that we talked about earlier, like categorization, use the batch inference capabilities and features from the feature store in order to make their predictions. All the feature metadata is also stored in a central metadata store, which then powers our exploration capabilities and our search and discovery capabilities of the features. Feature processing is a key component to produce great features as well. To that end, we have two platforms that enable feature processing in two different contexts. The first is a stream processing platform, which has a high throughput beam-based stream processing capabilities that produce features to the feature store in near real time. The other platform uses Spark feature processing in order to read from the data lake and then produce features into the feature store. You will hear a lot about our Spark system called Spock in another talk in the OpML, and you will be able to look at how the system is implemented there. So once the features are produced by either of these two platforms, it flows into both the online and offline feature store, from where model training and model execution can start utilizing these features. In order to talk about how we use this for model training and how we built a platform around model training, I hand it over to Toby.
All right. Let's assume we have created some features via the feature processor, and they have made their way into the offline store so that they can be used for model training. As Srivathsan mentioned earlier, model training is another offering of our machine learning platform. And we fundamentally believe that developing and shipping machine learning models isn't really that much different from your usual development and shipping processes for regular software. To that effect, the individual steps of developing and shipping machine learning models may be a bit more complex than your average Maven build to build your application. For that reason, we have decided to use Argo Workflows as the engine behind our platform. These allow us to get the more complex training scenarios, for example, the one that we see here on screen, in a more codified session. What we're seeing here is a training workflow which is partitioning data, then preparing that data for training, actually training the model, all of this in parallel, and then producing a trained model artifact as its output. We want to hide away most of the complexity that is inherent in such a step from our users, which is why we have decided to go with a config-driven approach. Such a configuration could look like this. This is a more simple example for our credit card approval model, which is the model that we have been using for all of our internal trainings as well. What you need to provide is essentially just the location of your training and validation data and a location for the output to be stored in. With this, our platform can start training your model. There's a few other things in here, like the artifact URL, where the container is being hosted that is needed for model training. And some other things like the resource configuration. For this one, it's just a simple configuration with just one instance. But as you saw earlier, examples could be more complex and use more instances. Another thing that I want to point out here is the tagging system that we have added. The name of the tag is billing, and it'll come in handy later when we talk about how we manage cost in our platform. So let's say you have trained your model with this platform and the workflow has run and produced a trained model artifact that you now want to deploy and try out. You don't really want to push to production immediately because your model could grant everyone a credit card that comes. So you want to just test it out in some of the pre-prod environments. And for us, we have essentially set up 4 different swim lanes. 3 of those are specifically designed to do testing or integration testing with the applications that are going to call this model, or just to performance test your model. This is very important for our customers so that they can really try out what they've built and make sure that it does what it needs to do. Another thing about such a centralized orchestration platform is that you can easily find some aggregated statistics about how your organization is doing when it comes to model development. How quickly are they moving from their dev environment to a production, and how many models have been deployed in the last week or month is something that we can easily figure out with this tool. When you've added your model to this platform, something that should be easy is to just have a single-click deploy. You want to deploy easy things, and what we've learned is that a simple UI, just like the one you're seeing on screen, really helps to lower the initial burden on the customer. We take care of versioning your model, and we provide live metrics that you can then use to create alerts. For example, how often is your model being called, or how long does it take for your model to respond, which you may want to alert upon. We also provide easy visualizations of how your model is doing in production, how it's set up, and what is currently happening. One of the more complex tasks that need to be done when you're deploying your machine learning model to production is to figure out how often it's going to be called and what the expected response time is. For the cash flow prediction model, for example, the product team could tell the data scientists that this model needs to be called 500 times a second, and we need a 200 millisecond response time from your model because it's very urgent. And for the data scientists, it may be pretty difficult to understand which instance types to use when deploying this model or how many of those. And for that, we have developed a tool to run a perf test in which you can essentially plug in these parameters, the maximum TPS and your expected response time, and the tool will try out different configurations for your specific model and see if it meets the requirements, and then print out a recommendation at the end. This way, you can easily get your model to production at the right configuration. But if you make it very easy to deploy models, you'll have lots of models deployed. And if people are testing things out, you'll have lots of experiments with sometimes more and sometimes less a discernible purpose. What is very important is that all of these things are going to cost your organization real money. And you need to be very upfront with the pricing of each individual model that is deployed. Whenever you click on the deploy button that we saw earlier, the window on the right will pop up. And you will see that for the number of instances or the different instance types that you're selecting, your monthly cost will go up or down. And this is very important for data scientists and for business leaders to calculate a return on investment on the individual model. If you are spending $5 per customer to do an awesome prediction, but it's not bringing any revenue, you may need to have the hard conversation of, is that model worth running? And our platform allows these conversations to be had with data backing it up, because you can clearly identify how much each model is going to cost for a specific configuration. Something that is also very important is the assignment of that cost. You may have different business units in your company. For Intuit, we of course have one for each application. And we need to make sure that each BU is built accordingly to what their use cases are costing. And here the tag comes back in that I mentioned earlier about the Intuit billing financial party. With these tags and the proper values for these tags, we can create something like this. A very detailed graph of the spending on machine learning models at Intuit in the last few weeks. As you can see, each of these bars, and some of them are so small and they're just combined to a black bar, represent a machine learning model. What we of course can do is look a bit deeper into this and select one of the models. So let's have a look at CatCat, our categorization model. As you can see, on July 17th, the cost for this particular model increased by quite a margin. And we can now go back and verify why this happened. Maybe there was a perf test going on. Maybe the developer deployed a few new versions of this model to try it out, and then undeployed those on the 26th again. With this, we can easily put up guardrails when it comes to cost, because each increase in cost should have a corresponding business reason. And of course, we can set up alerts on these things to make sure that the cost doesn't run away and there's no control over it. So now you have lots of models running in production and you've controlled the cost. What can go wrong? Well, let's have a look at this jellyfish library. It's a library that is doing approximate phonetic matching of strings, and it's something like something that a data scientist could use. The more eagle-eyed observer will already have realized that the pip install command looks a bit odd. Yes, the first L in jellyfish is actually a capital I, and this library is doing much more than just approximating and phonetic matching of strings. It was uploaded to the PyPy repository in December of 2018 and stayed there for about 1 year. While it was there, any user of this library would have been able to do the phonetic matching of strings just like expected, but the library would have also exported all of the SSH and GPG keys on this host, as well as sent information about the file system to a potential attacker. So there's a lot of things that can go wrong. What's important to realize is that ML models are just as vulnerable to these kind of attacks as any other piece of software. And these attacks could have been caught by other remediating controls in our organization, but we as the ML platform need to do our part. So we have integrated centrally with the CPD tool that another team at Intuit is developing, which scans containers before they go to production. We make sure that the source image is validated, that standard frameworks are being used, and that the image is properly certified and signed before it goes to production. On the runtime, as Srivathsan mentioned, we are fully in AWS. So we have secured our endpoints with VPC endpoints that restrict access to only those that should have. We are using the VPC flow logs to monitor the traffic that is coming to and going from those model containers. And we have security groups in place that make sure that outbound traffic can only go to trusted sources. This way, the jellyfish vulnerability would have not had an impact on our models, but it is important that everything is in place just to prevent this. In addition, we have the KMS encryption for any data at rest, and we have least privileged IAM roles to make sure that any interaction with a service is done by the parties that are allowed to do so. Another thing with security is compliance. There's quite a lot of complex regulations out there. Most known is probably the CCPA and GDPR compliances that you need to have when customers want to see what you have on them and potentially delete any data that exists in your system. Something that is a bit more common is PCI compliance. That is necessary whenever you're dealing with credit card data, and any model that is trying to predict fraudulent transactions with credit cards will need to have this compliance. Specifically for Intuit, there's a few more compliance regulations that we need to adhere to. Indoor and NIST are regulations that are important when interacting with government services. And of course, when we prepare your taxes, we do need to interact with those services. So the platform can make sure that itself is compliant with these regulations, and thus any model running on it is compliant. This takes away the burden of being compliant from the model developer itself, and it also makes the process of achieving compliance a bit easier for the products. If TurboTax can say any model that is running on the platform is already compliant, if the platform is compliant, it makes it a bit easier for them to achieve that compliance as well. When you automate the necessary controls that are necessary for the compliance, you can also make sure that any future model that is running on your platform will be compliant. Thus, doing it once and automating it and then not needing to redo it for every model really saves time and gives the speed that we need to our model developers. So in summary, the learnings that we've had is that you can really accelerate the deployment through self-service APIs. The UI that I showed earlier is a good example of lowering the initial barrier and then exposing the backend APIs to anyone who wants to programmatically start any of these processes is the nitro boost to getting to production. Using the GitOps approach and using CI/CD principles that have been proven to work in regular software really helps as well. And taking care of the productionalizing and operational things that data scientists no longer need to do, like setting up monitoring and alerting, as well as security, is also something that is off their plate and helps them focus on developing models. Using workflows for the individual steps in the model lifecycle helps, for one, because the operations can be more complex, but also because they're extensible and it is easy for customers to really change up the workflow and make it their own if the model requires it. A feature store that has curated features really helps you with the model quality. A model and the predictions that it produces is really dependent on how well the features are curated and how accurate they are. So getting a feature store where data scientists can explore and share proven features is really something that helps out in this regard. So what's next? We have lots of things that we still want to do with our platform. The first thing is that we would really like to create a custom machine learning operator. This would help to orchestrate all of the individual steps in the model development lifecycle, and then essentially have a declarative management so that any changes to this can be documented in code, and you have a clear source of truth with the infrastructure as code principle. Another thing that we'd like to invest in is a managed notebook service so that data scientists can collaboratively find the data and visualize it before going to production. Thank you so much for your attention. If you have any questions, you can email us on the emails listed below. Thank you.